Hello everyone, my name is Tasneem Safdari and in today's video I am going to explain question number 3 of end semester of data science. In the previous videos I have discussed question number 1 and question number 2, both part A and B, and in today's lecture we are going to discuss question number 3 part A and B both. So let's start. So question number 3A part states data. What is data wrangling process? So data wrangling, also called data munging, is the process of converting raw, messy, inconsistent data into a clean, structured and usable format for analyzing or machine learning. So what we get is a raw data. When we collect information from various sources, we get raw, messy and inconsistent data, which is data can be varying, inconsistent. So we need to convert it into clean, structured and usable format so we can analyze it or we can use it for ML, which is machine learning. So we have raw data and we are converting into a clean, structured, filtered data. So it involves cleaning, transforming, validating and organizing the data. So we clean, then we transform it into particular what we want, we validate whether it is correct or not, and then we organize it. So these are the 4 steps. So steps of data. So we have steps of data wrangling. So first is data discovery or data understanding. Understand what data is available. Like we'll check the formats, like it is in CSV, JSON, Excel, databases, logs. So we need to understand what is the data which is available to us, and we check its format. Now we'll identify the types, whether it is numerical, categorical, date, text. What is the type of data? We identify that. So we find numerical, categorical, date, text. So this is all we identify its types. Second is data structuring. Like we convert unstructured, semi-structured data into structured form. So we are converting it into a structured form. Example, extract columns from text logs or JSON fields. So we are converting, we have unstructured or semi-structured data. First we got data, we have identified what our data is, what is the type of our data, and then if it is unstructured or semi-structured, we convert it into structured form. Align data fields from multiple sources. We have data from various sources, not from a single source. So we'll align those data fields from multiple sources. Third is data cleaning. This is the most important step. Data cleaning, we got data, we structured it. Now we need to clean the data. Like how we'll handle the missing values, like remove row or column, replace with mean, median, mode. So missing values, we'll remove row or column which is containing the missing values, or we'll be replacing it with mean, median or mode, or using KNN and regression imputation we can handle or fill in the missing values. Second is removing duplicates, like drop repeated rows and fixing inconsistent data. Like we have Mumbai with all small or first capital letter or all capital. So we'll be converting it into a single format where either the first letter should be capital or entire should be capital. So we are converting it into a single format, and the date format should also be corrected. Like sometimes we write date before or year before, so it should be converted into a single format. Handling incorrect data types, like convert strings into numbers, text dates into proper date time. So this incorrect data type should be handled, should be converted into proper data types. Now handling outliers, remove or cap extreme values. Fourth is data transformation, scaling, normalization, encoding, categorical variables, then aggregation like sum, mean, feature creation, extracting month, day, domain, etc. This is data transformation. Then a data enrichment, which is adding new useful features. Enrich means enrich is to fill. in with, so we are filling it with new useful features. Example, from date add month, week, year, address, exact city or pin code. So we'll extract from date, we'll extract month, week, year. From address we can extract pin code, city. Combine data sets to add more attributes. Data sets are combined so we can add more attributes to it. Sixth is data validation. Check if cleaned data is correct and consistent. So we have collected the data, we have cleaned it, so whether it is correct and consistent. Validate ranges. Age must be from 0 to 120, so this should be the ranges. Validate formats. Emails, phone numbers, so this should be validated. Check referential integrity if combining data sets. If we are combining the data sets, referential integrity should be checked. Data storage. Save clean data sets. We have cleaned the data, we need to store it in the proper format. So like in CSV, databases, data warehouse, cloud storage. So here the final file could be saved like CSV file, database, data warehouse, cloud storage. So this is the data storage. Example of data wrangling. Like we have raw data, we have this raw data sets, in which data set which we have name, age, salary, city and date. So name, age, so here age is NA, means empty, then Mumbai, and then here date you can see in every different format, Mumbai in different ways. So fixing values, like age, will replace it with mean age. So mean was of this was something around 67, so we have filled in the age with mean. Now remove duplicate. So duplicate rows, like Rahul, this is duplicate, same entries both, so we'll remove that. And age 150, which is unrealistic, replace using median 25. So with median it is replaced with 25, it is unrealistic. And salary minus 2000, it is invalid, so we'll replace with 0 or we'll remove the entire row. Now standardized format, like Mumbai is written in different ways, so we'll standardize it into one. And convert date to standard format, like year, month, date. So this should be converted into standardized format. So after doing all this, the final or clean data set which we got is this. So we have removed the Rahul 2 times. We have the age, we have filled in with median, and here also age we have filled it with mean, and salary cannot be negative. So final summary, data wrangling is crucial pre-processing step that converts raw, noisy, inconsistent data into reliable and structured suitable for statistical analysis. So what we get is raw, noisy and inconsistent data. So we convert it into useful data using statistical analysis, machine learning and reporting. It ensures higher model accuracy and trustworthy insights. So this was about question number means part A of question number 3. So we have studied data wrangling and how can we remove the errors and how can we clean the data, and we have looked it through an example as well. Question number 3, part B, difference between errors and artifacts in data cleaning. Explain any 2 imputation techniques. So what is difference between errors and artifacts? So errors are incorrect, wrong and invalid values in data set. So we have a data set. So errors can be incorrect, wrong and invalid values caused by manual entry mistakes, measurement failures or system issues. Error must be corrected and removed. We need to identify it and we'll corrected or removed. Like when we are manually making entries, we make mistakes that time, measurement failures or system issues. So it is wrong and invalid values in the data set. Example, age is 250, which is impossible values. Salary minus 5000, again it is invalid. And spelling mistake, like Mumbai we have added 2A. Kolkata 2T. So this is the spelling mistakes and wrong formats like date. So the format should be normal, should be same, and age. These are the errors which we make in making entries in the table or in a data set. Artifacts are unwanted distortion or patterns introduced during data collection, transmission, or pre-processing. So it is unwanted distortion or patterns when we are collecting data, transmission, and pre-processing, not actual errors but misleading variations. So it leads in misleading answers and outcomes. Need filtering, smoothing, and normalization. Example is noise in sensor data, duplicate data due to system logs, extra spaces, special characters from scraping, pixel distortion in images, interference in ECGs or EEGs signals. Not tabular difference. Wrong errors are wrong and incorrect values in data, and artifacts are unwanted pattern noise created by devices or pre-processing. Cause human entry mistake, device malfunction, signal noise, scraping, compression, makes data false or invalid. Effect is it makes the data false and incorrect, and it causes bias or misleading variation. Correction, removal, validation, filtering, smoothing, and normalization. Like age is -10. So it is or misspelled city. So these are the errors which we make while manually making entries, or incorrect values which we insert. And artifacts like noise in sensor data, it is unwanted pattern or noise which occurs when we are pre-processing, cleaning, or transferring data. So noise in sensor data, duplicate logs, pixel distortion. So this is the example of artifacts. Explain any two imputation techniques. So imputation means filling missing values. So mean, median, mode, it is simple and very commonly used. Like we can put the values with mean, like here we have a marks and NA. So we'll find the mean of that particular column and we'll fill in the missing value with this mean. Now median. Median will find the median because mean gets affected by extreme values. If we have extreme values, so mean might get affected, so we'll filling it median. And mode means means most occurred value, so we'll fill it with mode. Next is KNN imputation. So K nearest neighbor finds the K closest row and uses them to fill the missing values. We'll choose a value of K which is usually 3 or 5, and we'll find the missing nearest neighbor with complete data. And for numeric, take mean of neighbors. For categorical, take majority vote. For example, we have a age column. If neighbors for NA are 26 and 28, so we'll find the average of both and we'll fill in with 27. And third, another method is regression. So build a regression model using other variables and we'll predict the values from it. If height is missing, so height equal to F, age, gender, weight, so we'll predict the height. So this is the regression imputation. So filling it with mean, median, or mode. And second is with filling it with KNN imputation. We have found the both nearest values of NA and then we have imputed the value in it. Now the final summary. Errors represent true mistakes in data, whereas artifacts are unwanted distortion caused by the collection data process. Both must be fixed to ensure data quality. Missing values can be filled using imputation techniques such as mean, median, mode, KNN imputation, or regression imputation to make the dataset complete and usable for machine learning. So this was all about question number 3. We have discussed both part A and part B in detail, and we'll be discussing the next questions in the next videos, which will be uploaded on the playlist. You can look to it for further explanation.